The second quantity is current. Current is defined to be the rate at which charge flows. Current measures charge per time. How much charge in a given amount of time? It's a rate. Symbol that we'll use to represent charge, or I'm sorry, current in equations is a capital I. What are the base units? What units go with current? Amperes, or amps of current. So we talk about there being 2 amps of current or 10 amps of current. Those are the base units for current. But if we understand that current is a rate at which charge flows, how much charge per time, then 1 amp of current is equal to 1 coulomb of charge every second. So 1 ampere is 1 coulomb per second. We need to have a good understanding of what a current of 1 amp represents. So when we talk about charges flowing, we tend to talk about things like electrons. So what's the charge on an electron? -1. -1, right? -1 what? Yeah, we don't know because they never gave us a unit in chemistry class. Okay. They just said electrons are -1 and protons are +1. And it's true that they have equal and opposite charges. So we could just say -1 and +1. But when we start trying to represent those in terms of standard units, it turns out that the magnitude of charge on 1 electron is equal to 1.6 times 10 to the -19 coulombs. So a single electron has a magnitude of charge that's 1.6 times 10 to the -19 coulombs. That's a really, 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 really small number. One amp of current is 1 coulomb passing a point every second. So how many electrons would you need to get 1 coulomb of charge? What do I want to have on this side? I want how many coulombs? 1. So what do I have to do to this side to get a 1? Divide by 1.6 times 10 to the -19. But if I do that to one side, I do it to the other side. So I get 1 coulomb is equal to 6.25 times 10 to the 18 electrons, which is a really, 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 really big number. 1 amp of charge means 6.25 times 10 to the 18 electrons pass a point every second. If you happen to be a large industrial motor and 1 amp of current flows through you, you don't even notice it. If you happen to be a human being made up of roughly 70% salt water and 1 amp of current flows through you, you may not notice that either because you may have died. Okay? 1 amp of current can be fatal, especially if the pathway includes the heart. This is the base unit. We're going to build circuits in the lab, and we're going to run current through. we're never going to get near 1M. If we do, we're in trouble. Because either you'll burn something up and I'll get mad, you'll kill yourself and your parents will get mad. Okay? Or, well, I can't think of a third, right? There's not any good that can come out of it. So don't break my stuff and don't kill yourself. Right? Neither works out well for me. One costs me money, the other costs me my job. We're going to be dealing on the order of milliamps typically. Okay? Thousandths of an amp. 10 milliamps, you will notice. Okay? If you become part of a circuit with 10 milliamps, you'll know it's running through. 70 milliamps can be fatal. Especially if the heart happens to be part of the circuit. So we have to be very careful on the line. So if you grab something with this hand and grab something with this hand, and there's a difference in potential between them, then current can flow. Right through your heart. It doesn't take a lot of current to do damage. So we have to be very, very careful here. In between the 10 milliamps and the 70 milliamps is this cool little value called the let go threshold. How do you get your muscles to move? Your brain sends electrical signals, okay? And it tells your muscles to move. But your muscles are going to respond to electrical signals, no matter where they come from. So if you have a wire that has current flowing through it, experienced people who've worked with wiring will never touch it like this. Because if you run a current across the palm of your hand or across the back of your hand, the muscular response is this. So if there's current through that wire, it's going to tend to make your hand do this. If that current is above what's called the let go threshold, it means the current in the wire is high enough so that no matter how much you look at your hand and think, I really need to let go, you can't. Because the electrical signal that you can send from your brain will not override the signal that's in the wire. So you can sit there all day long thinking, bad, really bad, should let go now, and it won't matter. What you need is either the current to stop flowing through that wire or a friend who loves you enough to hit you with the 2x4. Okay. Because if they hit you with the 2x4, then maybe they'll knock you off the circuit. If you have one of those friends who doesn't understand what's going on, they come and they grab you by the arm and go, let me help. Oh, yeah, now they're part of the circuit too. Okay? And they're not going to help you much. So the 2x4 is a much better option. You really have to be careful with this stuff. Okay? So we're going to be dealing on milliamps here. Be careful with units. There are people that argue with me every year because they'll take a test on circuits and they get a current that's 3 amps and my key says 3 milliamps and they want partial current. But I've got the answer. I'm like, no, you didn't. Okay? Because if I put 3 milliamps and you put 3 amps, if we were to reword your argument, what you're saying is, I was only off by a factor of 1,000. Can't I get some partial credit? And no one would argue with you on that. They'd go, you're a fool. No, you're off by a factor of 1,000, which means you're not even close. So when you think about correct answers here, they may have a sign, a positive and negative. They have a value, a magnitude, the number, and they have units. If any one of those is wrong, your answer is wrong. Throwing off a prefix is significant. Worst case, or best case for you actually, is you're only off by a factor of 10, which means you're wrong. But more than likely, you're going to be off by a factor of 100 or 1,000 or 1,000,000, which means you're way wrong. Pay attention to prefixes.